In this video, we'll discuss about very important types of relation. Okay, so what we are discussing now is types of relations. Now, in the types of relation, there are three very important. The first one is what we call as a reflexive relation. Second one is called as symmetric. The third one is called transitive. Now, these are the three types of relation. Now, what is what? Very simple to understand. Now, when we talk about reflexive relation, suppose say you have some set. Okay, assume that you have a set A. Now, in this set, say you have an element A, B, C, D like this, so on and so forth. All right. Now, what reflexive basically tells you is that for all A belonging to A, okay, so the A is an element which belongs to the set A. So A belongs to A. There exists a relation R which contains an element, or you can say a relation A comma A. Okay. Now how we write it is that A comma A belongs to R. Okay, A comma A belongs to R. Now this is basically what we call as a reflexive relation. Okay, in the sense, suppose if you have, let's say we have a set A is equal to, say 1, 2, 3, 4. Now we are going to define a relation. So always relations are defined as A comma B. A and B are two elements such that now you define the relation. Okay, like something like A is equal to B. Okay, here A and B belongs to set A. Alright, now here look at this one. Suppose if you write A comma A, that means it's nothing but saying A is equal to A. For example, if A becomes 1, then we can say that 1 is equal to 1, isn't it? It's possible. So 1 is equal to 1 or 2 is equal to 2. No matter what the number you are taking, this relation R is always true, correct? So what we are defining that A comma A, that is what we call as reflexive relation. Understood? Now we'll look into the next one, which is a symmetric relation. See, symmetric meaning what? Here we take symmetry meaning what? Equal on both the sides, correct? Like a mirror. Mirror is symmetric. The image and the object both are symmetric. So here what we are taking two elements. Generally we take the elements. So for all A comma B belongs to R, some value A comma B belongs to R, then B comma A also belongs to R. Then it is symmetric. In the sense, if you have, let's say, see this A is equal to B, take the same relation. Okay, if you're taking same relation, or maybe I can take some other relation, maybe like A is equal to, A is greater than B. Not greater than, maybe A is greater than or equal to B, something like this. Okay, so here in this case, see if you have, let's say A comma B, right? And you know that A is equal to B. So here you can say if A is equal to B, then B is also equal to A, correct? Now A is equal to B is what? A comma B. This represents A comma B. B is equal to A represents what? B comma A. So this is basically symmetric. Now the last one is transitive. See, when we say transitive, here for all A comma B and B comma C belongs to R, then A comma C belongs to R. Here I can talk about maybe a less than relationship. Suppose if I say A less than B, B less than C, then A is obviously less than C, isn't it? So this is transitive basically. Okay. Now see, suppose if you have some relation which is reflexive, symmetric as well as transitive, then we have a special name for it. We call those as equivalence relation. See, equivalence relation. These relations are those which are all the three. That means it is reflexive, okay, and it is symmetric, symmetric as well as transitive. It is all the three. Suppose if you have a relation which is true for all the three, like it is reflexive, symmetric as well as transitive, then it is going to be an equivalence relation. All right, so these are the types of relations what we have. Now in the next video onwards, we'll start with problems. Okay, once we do problems, you guys will understand better as to how we apply this in the problems.